Friction is the resistance to motion of one object moving relative to another. It is not a fundamental force like gravity or electromagnetism. Instead, scientists believe that it's the result of electromagnetic attraction between charged particles in two touching surfaces. There are 4 types of friction: static, sliding, rolling, and fluid friction. So for my first example, I made a question here. A car has a mass of 300 grams. When you slide it against the floor with 4 newtons of force, it accelerates at a rate of minus 1.1 meters per second. What would the coefficient of friction be between the car and the floor? So our first step would be to gather all the information we can find in the question. We have mass, 300 grams. We have force applied, 4 newtons. And we have acceleration, minus 1.1 meters per second. So our first step would be to convert grams into kilograms. So first, all we want to do is get 300 divided by 1,000. And that gives us 0.3 kilograms. To get our force of friction, we will first punch in the numbers into our formula. So we have 4, which was our force applied, our force net, minus 0.33 newtons. And now we want to isolate force of friction. So we can subtract that from this side so we can isolate that. We also have to do that to this side, because what you do for one side, you have to do to the other. And we end up with 4.33. Over here, I divided each side by -1 to turn the force friction into positive. So after that, our next step would be to find mu. And we can do that by first getting our Fn, which is Fn equals Fg. So we know that Fg equals m times g. So we can do mass times gravity, which gives us 2.94 newtons. So let me just do that. So 0.3 times 9.8, right there, 2.94. So after we have Fg, we can punch everything into the formula. And over here, where it's Fn, we have to divide that by 2.9 since we want to isolate mu. And what we do to one side, we have to do to the other, so we do the same over here to 4.33. Once we divide that, we should be left with 1.47. So 4.33 divided by 2.94. Okay, so that matches with our answer. And that's how to do this question. So for my second example, I made another question. A 600 kilogram car is on a level road going at 30 meters per second. How large is the retarding force? Assume it's constant. The car is required to stop at 70 meters. So in this case, we will need to find our acceleration. And to do that, we'll have to use a kinematics formula. So we have to gather all the information we can find from the question. So the car has to stop. So our velocity final will be 0. And our velocity initial is 30 because the car is going at 30 meters per second. 2 is in the question, the kinematics formula. And our acceleration, which we're trying to find, and the distance is 70, which is written right here. So next we have to punch everything into our formula. Once we've punched everything into our formula, we can start calculating. So 900, right here, we got 900. 2a times 70, which is 140a, right here. So now we have to isolate acceleration. We can do that by first minusing 900 from each side and then dividing by 140 to isolate the A. So we're left with minus 6.43 meters per second squared. Now that we have our acceleration, we can find our force net. So 600 times minus 6.43 minus 3,858 newtons. So for part B, we have to find the max coefficient of friction between the tires and the road. So our first step is to get force gravity. So that's 600 times 9.8 5,880 newtons. So now that we know our Fg and we know it's equal to Fn, we can start punching everything in. So 5,880 divided by 5,880 to isolate mu, we have to do that to the other side too. So we get 0.656. So I've rounded that up to 0.66. And that's it for my two examples. For my demonstration, I'll be using a toy car and sliding it down two straight surfaces to see how friction can affect the distance. For surface number 1, I'll be using oak wood. So as you can see, it went a little over 23 inches. So for surface number 2, I'll be using a towel. And you can see it only went about 7.5 inches. We use friction throughout our daily lives whether we know it or we don't. Without friction between our shoes and the ground, we wouldn't be able to walk properly. If there is no friction, all of us would be sliding all over the place. While walking, you're pushing your foot back as you try to step forward. Friction holds your shoe to the ground so you can walk around. Another example would be when you're driving to school or to your job, friction in the tires helps the car move forward. The tires can grasp onto the ground and push the car forward.